There are two parts in TCP/IP. One is TCP, next one is IP. When you talk about computer networks, there are 2 to 3 models. One of them is OSI reference model. OSI stands for Open System Interconnection. This is the way you are transferring the data from computer to the medium, transmission medium. Dear students, welcome to Computer Science Revision classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us continue our discussion with respect to the topic networking concepts. So in this session, we are going to talk about OSI reference model and TCP/IP reference model and transmission medium. Now let us see. First one is what is ARPANET. So what is ARPANET? It stands for Advanced Research Project Agency Network. That is the full form of ARPANET. It was the world's first networks developed by US Department for Defense and used by projects at universities and research laboratories in the US. So ARPANET uses TCP/IP, which would be the form of the backbone of how the internet works. So here, if I talk about computer network, and here in ARPANET is the first in the world, the first network. It is developed by US in the Defense Department. And the ARPANET in the US Department, so they have started with the Defense Department, then they have tried to connect different universities in US and different research laboratories, and they have succeeded in connecting different departments. So this is the ARPANET. This is how the computer network started. So this is the world's first network. So this is ARPANET. It stands for Advanced Research Project Agency Network. Next definition is OSI reference model. See here, when you talk about computer networks, there are 2 to 3 models. One of them is OSI reference model. OSI stands for Open System Interconnection. So please remember this. OSI stands for Open System Interconnection. So it is divided into 7 different layers according to different function. So OSI reference model, which is the first model or an old model of networking, and it has 7 layers. 7 layers are for different functions. It is called as a 7-layer model. Now look at the example here. So this is how we assume this, or this is how we represent the OSI reference model. So this is host A. I'm talking about one computer, the host computer, and host B is nothing but destination computer. This is communication between host and the destination, how it takes place. And in OSI reference model, it is a 7-layer model. So here, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical link layer. And this, whenever you talk about network model here, in OSI reference model, the same model is applicable at the host level at the sender, and same model will be applicable at the receiver or the another host here or receiver. So this is a sender and receiver. All of them, they will come under this reference model. And here in this model, the data will transmit from physical layer to application layer, and through the cable or medium, it reaches a destination in this direction, or from application layer to physical layer. And here, these 7 layers will be having different applications, and all these layers will work with different protocols for different layers. So this is a 7-layer OSI reference model. Now let us see what are all the functions of different layers in OSI reference model. The first one is physical layer. This is what you have seen, physical layer from the bottom here. So this physical layer, it concerned with transmitting raw bits over a communication channel. So this is the way we are transferring the data from computer to the medium, transmission medium. Then data link layer, it is to encode and decode raw data to form frames or packet. So data link layer, it is responsible for converting the raw data into frames or packets or nothing but encoding, decoding at sender and receiver end with respect to its standard. Network layer, so it determines how the packets are routed from source to destination. So the meaning is nothing but it is going to look for this particular layer, looks for the best path between the host and destination to send the messages from sender to receiver or from host A to host B. Transport layer, this layer is concerned with actual delivery and error checking in the data once it is arrived. So what is the function of transport layer? See, once the data has been traveling from physical layer up to network layer, then transport layer, it makes sure that actual delivery of the data, or it guarantees the data from host to destination or from sender to receiver computer. So that is the responsibility of this transport layer. Next one is session layer. So it is responsible for establishing connection between communication machines. So session, if you want to transmit the data from one to another computer or host A to host B, a session has to be established between two computers or two devices. So responsibility of this session layer is to establish a connectivity between two devices. Next, presentation layer, it is concerned with syntax and semantics of the data that is to be transmitted. So the meaning here is, as the data is transmitting over the network, so any sorts of data encryption, data encoding, decryption or decoding takes place in presentation layer. It is a sort of security to the particular data in the form of frames or packets. Next, application layer. So this is the last layer here, and this layer provides access to various network services, and it contains variety of protocols like HTTP and FTP. So application layer, it responsible for providing interface or in the variety of protocols like HTTP and FTP. So here, as I told you in the beginning, the data from the host transmit from it is going to travel from host, from physical layer up to application layer, from the host level at the destination or at the host B or the receiver end. The data moves from application layer to the physical layer. That is how the data transmits in a network. So this is OSI reference model, 7-layer model. Next we talk about TCP/IP reference model. This is another method of networking. OSI reference model, it was the first model, a old model. Now later on, nowadays we are using TCP/IP reference model for data networking. So here TCP/IP, here there are two protocols. TCP/IP itself is a protocol. So there are two protocols, TCP and IP. So TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. See, you might have heard the word IP address. So this is the meaning of IP protocol, nothing but Internet Protocol, or it stands for your IP address of any computers in a network. So TCP/IP is the base communication protocol of the Internet. So the main protocol with the TCP/IP reference model is TCP/IP, and it is a base protocol, and the part of TCP/IP uses numeric IP address and to join the network segment, and TCP part of TCP/IP provides reliable delivery of the messages between network computers. As I told you, there are two parts in TCP/IP. One is TCP, next one is IP. So here IP stands for numeric IP address. That is how a computer will be recognized in a computer network. And another part of TCP/IP, that is TCP, it responsible for guaranteed delivery of a data or a message to the destination or to the host B. This is the function of TCP/IP protocol in a network. When the information is sent on the internet, it is generally broken down into smaller pieces called packets. So we have seen in the previous slide, the data sent from computer, the raw data will be broken down into number of frames or number of blocks and number of packets. These packets are transmitted by different routes and then reassembled at the destination. So if the data, if there are more than, generally there will be a more number of blocks or more number of packets. So the data in the network, it may not transmit all the packets in series or in serial. So the different packet reach the destination at different time or through different path. But at the destination end, all the packets are reassembled to make a proper data at the destination end. So this is the responsibility of TCP/IP protocol. And TCP part is responsible for dividing the file or messages into packets and putting them back to in the correct order at the destination, and to make sure that packets are not lost in transmission. So that is the responsibility of TCP. And every computer network has a unique address known as IP address, that is IP protocol. The IP address, generally it is written in 4 decimal numbers, that is 172 dot. In between we have a dot, 16, 5 and 200. So this is the version IPv4, this is a version 4. Nowadays, as and when the more number of computers are increased in the network, so we are using IPv6 format of IP address. Now let us see the difference between this TCP/IP and OSI reference model. As I told you, this is a 7-layer model, and here it is a 4-layer or 5-layer models. And here you can compare the different layers, and here data link and physical link layer. So it will combine to form a network access layer in TCP/IP reference model. Network layer as it is, transport layer is as it is, and application layer, presentation layer, session layer, all the 3 of OSI reference model forms a single application layer in TCP/IP reference model. So these are 2 different networking models. Now in this next slide, we will see what are transmission medium. The cable that connects 2 or more computers for communication is called as transmission medium. So we know a computer network. So it's a connection of, or is a collection of different types of computers in a network. And how do we connect each other? We are connecting each computer, each devices in a network through a cables. The cables are called as transmission medium. So here, transmission medium, we have different types or category. One is guided medium. Under that we have twisted pair cable, coaxial cable and optical fiber. These are different types of cables for networking. And under unguided medium, we have radio waves, microwaves, satellites communication, infrared waves and laser waves. These are all different types of transmission medium, and this one is guided, second one is unguided medium. Now let us see, the first one is, what is a twisted pair cable? This is one of the guided medium. So here, the twisted pair cable is used for voice transmission as well as data transmission. This is a type of communication medium we are using for transmitting voice data as well as data. Then, when twisted pair cable is used for voice transmission, it is called VGM, voice grade medium. And if it is for data transmission, it is called as data grade medium, DGM. Now look at the picture of this. So here, twisted pair of cables. So if you look at this, these are the normal cables, these are the cables, and these are twisted. These are twisted pair cable, and this is another one type of cable that is called STP connector here. There is a shielded twisted pair cable, and here individual cables or the space are shielded. Again, you have one more shield and outer jacket here. So this is STP, one type of twisted pair cable. And here, look at the same diagram here, twisted pair cable. And there are 2 types of twisted cable here. One is UTP, unshielded twisted cable, and here a pair of wires that are twisted around each other to minimize the interference. So the meaning here is, observe this is one pair of cable here, and this another pair here, and all these pairs are twisted and have an interference and here, see, this is an example for unshielded twisted pair cable, that is UTP cable. Example is telephone and even Ethernet cables are commonly example for UTP wires or cables. Next one is STP cable, that is shielded twisted pair cable, and here it comes with shielding of individual pairs of wires which further protect it from external interference. So if you observe this diagram and if you are in the previous diagram, this is unshielded. Only we can see the paired cable and these two are not shielded here. But if you look at this diagram here, this is STP, that is called shielded twisted pair cable. If you observe this is one pair of cable, have a shield here. This is one shield. Again we have, this is called overall shield, and this is outer jacket. So this is how the cable is, that is STP cable, and advantage is that it protects from different types of external interference or disturbances. This is STP, and advantage is that it offers greater protection from interference and crosstalk due to shielding. And here advantage is that as it has a more number of shielding cables here, so here it is protection is more here. Like, what is the drawback of disadvantage is that it is heavier and costlier as compared to UTP cable. So this is STP and UTP cables, types of twisted pair cables. Another type of guided medium is coaxial cables. What are coaxial cables? Coaxial cable consists of a solid wire core as it's the center that carries the signal. If you observe this OF, this is the cable here. This is the central core. What you can see here, that is the central core. That is a core. That is where the signal carries or pass through this central core device. Now here a plastic layer provides insulation between the conductor and the metal shield. And here this is a plastic shield here. This is a plastic shield is going to provide the insulation between the conductor and the outer metal. See, this is a conductor and this is a metal here. Outside this we have a plastic shield. It is suitable for high speed of communication and widely used for television, cable and in cable TV network. So observe this, it is a type of coaxial cable and it is an example for guided medium transmission. Next one is, we have under this coaxial cable, we have types of coaxial cable. One is thick net and thin net. See, this is generally what we use the cable here, and there are thick net and thin net cable. The thin net cable is a thin coaxial cable used for 10 based the standard insulations of Ethernet networking, and it comes with the RJ58 coaxial cabling connector, and that is 360. This is the properties of thin net cable or coaxial cable. This is a thin net cable here. So, and here next one is thick net cable. It is 10 base 5. This is 10 base 2 thin net, and thick net is 10 base 5 standard. And here the cable contains a solid center conductor, and surrounding this conductor is insulating filler made up of foam as well as shielding braid. So this is what I'm talking about. This is a foam here, and you can also one more shield here. Second one, this is the outer jacket here. So this is a type of coaxial cable. One is thin net and one is thick net. Student, so far we have discussed about the OSI reference model, TCP/IP reference model and transmission medium. Let us continue our discussion in my next class. Thank you so much.